I mean, if you don't have a PG in geology at the university level, they should have all the reasons to support you, in fact, to start,
Yeah.
to start a PG department. Should be other way around. Yeah.
Yeah, they should.
They should.
Yeah.
Because the college which I studied in Indore, that is Holkar Science College, that was the only college in my entire university which was having post graduation in geology.
Okay.
And when I entered, my father was transferred somewhere else, and I had to study at Indore. So I had to pursue geology. So I went to Holkar Science College. They said all the seats are full.
Okay.
I said, how many seats are there? They said 6. Only 6 seats were there in PG. So I wrote to the government. I mean, my father wrote to the government that we have been transferred. So one seat was increased for me.
Very good. Very good.
So we had 7 students passing out that year, and that was with the consent of the government and the university. And I am really grateful to the government also, the sympathetic government that we had, and the university also. And the next year, when I topped in the MSc previous, I was made the member of Board of Studies in geology. So, so I again advocated in the Board of Studies also that we should have a department of geology in the university also.
Right.
But to your surprise, there is still not a department of geology in my university, though we have a very good and very vibrant department of geology in my college, from where I post graduated. So the department is there in the college, and it's a wonderful department. The kids are really bright.
In fact, in our college also, we have enough facility and the infrastructure for PG course also.
Must be. I saw the posters that Dr. Pramod shared with me, and I was really thrilled to see that you are carrying out such good activities.
Yeah.
So, and geology being, the science which caters to the society directly.
Yeah.
I mean, there is no other science which caters to the society so directly.
Yeah.
Though, I mean, I'm not aware how many professors of other discipline are here, but still,
I myself is in physics.
Okay. But still, I believe that the student who is studying in MSc Physics may not be able to contribute that much as the student who is studying MSc in geology. I mean, pursuing geology. You know why? Because physics is a very highly developed science. Geology is still in a developing stage, and we are really connected to society very well. We can go to the villages, we can go to different mining sites and all that, and start working right away. A physics boy may not be able to contribute that directly. Of course, he would be working in the lab tirelessly for about 25 years, 30 years, and then his innovation might come, may come, and will come fruitful for the society. But a geology student can start with.
In fact, we have seen many postgraduates in geology directly self-employed, immediately on the ground. Maybe in the mining or maybe in groundwater.
Yeah, of course.
Employed.
You know why? Because the practical applications are so good.
Yeah.
Practical applications are so, wonderfully well in geology. That is why we are well connected to the society, the needs of the society, basically.
Right.
That's right.
Yeah.
In chemistry, you might be having an Avogadro or Boyles or Charles once in centuries.
Yeah.
But in geology, you would be finding a geologist helping the society every day. I mean, that's how it happens, because we deal with natural resources.
That goes with the basic need.
Basic need, absolutely.
Yeah.
Absolutely. What time we start, Dr. Pramod?
Yeah, and another 2 minutes, sir, we'll start.
Okay.
We have 30 members. People still they are.
Yeah, I'm 31. That's good number.
Yeah.
For a Sunday crowd.
Yeah.
So, Sunday is good.
Shall we start, sir?
Sure. Go ahead.
Yeah.
Whether the chairman is there, SRA?
That's what I'm trying to
reach out to him.
I am here.
He is there, it seems.
Good morning, sir.
Good morning.
Yes. In fact, I was waiting for you only to join.
I have joined actually.
Okay. So let's start. Dear honorable members of Geological Society of India, honorable members of Mining Engineers Association of India, and my dear colleagues from GSS College, Belgaum, invitees, guests, and my dear student friends. Today we have with us renowned geologist and consultant Dr. Sudhindra Mohan Sharma from Indore. I have heard him from our Rotary Literacy mission, that is for all Rotarians. We have many lectures to know about Rotary, etc., and its activities. And fortunately, Dr. Sharma was our mentor in one of our RLI course. So I was even happy to know that he was a geologist. He is a geologist. So I invited him for today's lecture, and he has happily agreed to be with us. And he'll be delivering a lecture on groundwater management for drinking water security in rural areas, and which is a very apt and important subject for all of us. On behalf of Geological Society of India, Mining Engineers Association of India, and GSS College Belgaum, I welcome you all for today's guest lecture. At the outset, I invite our college principal, Dr. N.D. Hegde, to welcome the gathering. Hegde, sir. Thank you.
Good morning, everybody.
Good morning.
Very good morning. Distinguished Speaker of the Day, Dr. Sharma, the Chairman of Mining Engineers Association of India, Belgaum Chapter, Sri S.R. Hegde, my colleague and the Chairman of Geological Society of India, Regional Center, Belgavi, Dr. Hanamgond, members of the Mining Engineers Association of India, Geological Society of India, dear students, and all those who have joined for this particular important lecture this morning online. At the outset, it gives me immense pleasure to welcome you all for this particular topic, a special lecture on groundwater management for drinking water security focused on the rural areas. In fact, when I saw the topic, I was extremely happy to know that the Department of Geology under the aegis of Geological Society of India has arranged a special lecture on this. As we all know, next to air, it's water. That's very, very important for sustaining life on this planet. Recently, we have come to know the importance of oxygen due to COVID. And hopefully, before we come to such a stage, realizing the importance of water for sustaining life, we need to do something so as to manage the available resources. As is well said by none other than the father of India, Mahatma Gandhi, that there is enough for everyone's need, but not for everyone's greed. So we all know the resources are limited. The population is increasing. And how do we get water, air, and all such basic facilities provided to each and every person on this particular earth, and more so in India? So it is not availability, it's the management that becomes very important. So it is necessary to know how to manage the available resources and see that everybody gets a part and parcel of whatever is available. So in this connection, today, Department of Geology, GSS College, under the aegis of the Geological Society of India, and also the Mining Engineers Association of India, has come up with this very important discussion on the water management, especially the groundwater management for the drinking purpose. I'm more so happy because it is focused on the rural areas. So we are these days forgetting the people in the rural areas. The focus is mostly on the urban areas where the people can buy water. People can manage water however it is possible. But in the rural areas, nobody is taking care of them. They walk miles away, fetching a pot of drinking water. So it becomes more important to have a focus on the rural side of India, which happens to be around 70%. So we have a very eminent geologist, a noted scientist who has worked enough on the water harvesting and the water management. And on this occasion, on behalf of GSS College, on behalf of Mining Engineers Association of India, and on behalf of Geological Society of India Regional Center, Belgavi, I extend a warm welcome to Dr. Sudhindra Mohan Sharma. Welcome you, sir. At the same time, I extend a warm welcome to the Chairman of Mining Engineers Association of India, Sri R.S. Hegde, and also all the members of the Mining Engineers Association of India, and also the members of Geological Society of India, and also my dear students for this program today morning on a nice Sunday. So again, I extend a warm welcome to everyone who is associated with this lecture and take leave of you. Thank you. Thank you so much.
Thank you, sir. Now I request Mrs. Priyanka Shinde to introduce our today's chief guest, guest of honor and today's guest speaker.
Good morning, sir. Good morning, everyone. Am I audible, sir?
Yes.
Yes.
It gives me an immense pleasure to introduce our today's guest speaker, Dr. Sudhindra Mohan Sharma. Sir is a well-known and successful geologist by profession with specialization in groundwater and water resource management and drinking water security. Sir is a double postgraduate in geology and applied geology, specializing in groundwater and mineral exploration with excellent academic background, topping university in both the courses. Sir has served Government of India at national level, being National Nodal Officer, National Drinking Water Security Pilot Projects, Ministry of Drinking Water and Sanitation, Government of India. Professionally, Sir has designed more than 400 mega rainwater harvesting projects with areas as big as 4,500 acres to 400 square kilometers across India, from Arunachal to Gujarat and from Punjab to Tamil Nadu. He is currently working on climate change, water management for Shimla and lakes of Indore. Sir has received many awards, recognitions. To mention a few, Sir is a recipient of Best Biodiversity Conservation Award by Government of Madhya Pradesh. He has also been awarded with Social Award Awaz-e-Indore. He is a dedicated Rotarian and has been awarded by Rotary as a Best Rotarian and a Rotary Ratna for the service in the field of water conservation, community service projects, and as a Best Editor for Rotary Bulletins. He is a multiple Paul Harrier Fellow, Rotary Foundation. Sir has also awarded by various social organizations for his work on water conservation. Sir is a panelist on various TV channels and many radio stations, news channels, to mention a few, Star News, Z News, India TV, etc. Sir has participated in Asian Cities Climate Change Resilience Network Conference on Climate Change at Indonesia. He has been a member of National Recognition Committee, India, on Water and Sanitation, Rotary International. Then Sir has also held various positions in Rotary, from President of Club, Assistant Governor to District Chairman of Water Conservation and safe drinking water. Sir has addressed till date more than 40 Rotary clubs on water conservation and environmental and Rotary subjects. He is a faculty trainer in Rotary Leadership Institute, and Sir has addressed many courses on topics like leadership, Rotary opportunities, ethics, team building, club communication, membership, etc. Sir is currently Secretary of Zone 4 Rotary Leadership Institute, South Asia, which is comprising 13 Rotary districts of North and Western India. Sir has been a member of Board of Studies in Geology of Indore University, Indore, and President, Geological Association, Holkar Science College, Indore. Sir's passions include water, environment, rural development, community service, and working for youth development. Sir has written many books, one manual of sustainability for Ministry of Drinking Water and Sanitation, and also Sir has published 2 booklets on rainwater harvesting and groundwater recharging. And Sir has also published numerous research papers and technical articles. Sir has been a keen interest in training and capacity building and has conducted numerous training programs for various engineering colleges and NIH Roorkee and many administrative and academics of government. Sir is actively involved in many activities like Sir has founded the project AWARE, that is Action for Water Recharging. That is a Rotary project which is carrying out the activities like mass campaigning on groundwater recharge, and also it is included creating awareness about the environment through various projects of Rotary. Sir is actively involved in various youth activities. Sir has addressed more than 270 schools and colleges at various locations like Delhi, Indore, Bhopal, Udaipur, etc. Then Sir has guided many PG project works. Sir is happily married to Mrs. Meenakshi. She is also active member of Rotary Innerville Club. Then Sir is blessed with a daughter and a son. With this brief introduction, I present before you all a very dynamic and versatile personality, Dr. Sudhindra Mohan Sharma. I welcome you, sir.
Thank you, Priyanka. And now I request Sudhindra Sharma sir to give us the.
Thank you, Dr. Pramod. Yes. Thank you, Priyanka, for reading out so well my introduction. And though I've written it myself, but I didn't know that it could be read out so well. So thank you very much, Priyanka. That's really wonderful. You presented it so well. Yes, I'm a geologist and I'm a proud geologist. And of course, there's some disturbance. Can you mute yourself 410? Can you mute yourself? Yeah, thank you. Thank you very much. So, being a geologist and being in Rotary, they are 2 wonderful combinations through which I could meet Dr. Pramod, and through those coincidences, I am here to talk to you all. Being in Rotary is a wonderful thing. It's really enjoyable for a number of reasons. One of them is that you can get to be friends with wonderful people like Dr. Nagaraj Hegde here, Dr. P. Krishnamurthy, Dr. Pramod, and of course the young friends like Priyanka, and you can get to know so many people across India. Water, of course, is one of my passion, and being a postgraduate in geology and then specializing in hydrogeology, water has been very close to my heart. And when my professors asked me, why did not you choose mining geology as a special paper or coal geology as a special paper rather than hydrogeology? What is there in hydrogeology? I said to them, sir, whatever civilizations have prospered, they have prospered along the banks of rivers or near the sources of water. So whenever, even if I am a geologist, if I work on water, I'll be somewhere close to the civilization, which I am not sure if I am doing something in the mining. So that is why I chose water as such. So of course, after that, that's a long story. I joined Government of India, and then I was heading the National Drinking Water Security pilots. And then I came to the real passion, that is the rural India. I mean, the rural India has always been a fascinating area for me to work in. Being a geologist, and that too in working in the field of water, I toured rural India extensively and saw their plight. So I would like to discuss groundwater management for drinking water security in rural areas of India, rural areas rather. I'd like to share a presentation, which is of course a long one. I don't know how much time do I have, Dr. Pramod? How much time do I have?
You can, sir, 45 to 1 hour, no problem.
45 to 1 hour. Okay. So what I'll do is I'll start with my presentation, and based on whatever time I have, because this is a sort of long presentation, but of course I'll cut it short maybe, or may not be required, of course, depending on my speed at which we can discuss these things. So this is talking about groundwater management for drinking water security in rural areas. And whenever we talk of groundwater management, and on topic like this, groundwater management for drinking water security in rural areas, I'm a keen student of words. So when you see this topic, in this topic there is a term groundwater, then there is a term management, then there is drinking water security, and then rural areas. When we see a topic like this, then you get to know that something beyond just geology comes in, something which is multidisciplinary because groundwater itself is a vast science, groundwater, and then add to it management. And then when you talk of drinking water security, we will discuss what drinking water security means actually. And then rural areas. So a lot of dynamics comes into it, a lot of sociology also comes into it, a lot of psychology also comes into it. So it's not just about geology here, it's not just about hydrogeology here, but as it unfolds, you would find that this is about the approach that we have, the approach towards application of groundwater sciences for drinking water security. How do you go about it? How do you tackle those special problems that rural areas have? But at the same time, there are certain advantages also that rural area has. And we will see that what advantages there are with the rural population, with the wonderful rural population that we have in India. And I say wonderful not because of numbers. It's wonderful because of its inherent knowledge. So we will see how drinking water security can be managed in rural India. Let's start with the story. The small story is that some people go to their village headman. We call that Sarpanch here in Madhya Pradesh, or Sarpanch here in Rajasthan, Gram Pradhan in northern parts of India. I don't know what it is called in your area, but Sarpanch, the headman, village headman, who is the political head of the village, of the Gram Panchayat. And they say, sir, we need water. The Sarpanch says, okay, I'll provide water. Villagers would ask a further question, whether it will be safe. The Sarpanch says, yes, I'll provide safe water, but only for drinking. It may not be safe for other usage. The villagers say, no, we want it for all our needs, whether it is drinking or washing clothes or housekeeping or whatever it is, we want it for all our needs. Sarpanch says, okay, I'll provide safe water for all your needs, but only for 300 days in a year. Now the villagers would say, no, we want it for 365 days. Right? The Sarpanch says, I'll provide safe water for all your needs for 365 days in a year, but to about 80% of the village. Now, the villagers say, we want it for 100% of the village. Of course, yes, we don't want it for 80%, right? Sarpanch says, okay, I'll provide safe water for all your needs for 365 days in a year to 100% of the village, but at a distance of 5 kilometers. Now, the villagers say that will be too far. We want it at a convenient distance. Sarpanch says, okay, I'll provide safe water for all your needs for 365 days in a year to 100% of the village at a convenient distance. But some of the village may get lesser water. Okay, depending on the pipeline pressure and the distance of the source and the kind of infrastructure that they have and the kind of overhead tanks they have or water reservoirs they have. Villagers say, no, everybody should get equal water. Okay, Sarpanch says, okay, I'll provide safe water for all your needs for 365 days in a year to 100% of the village at a convenient distance with equitable distribution, but may not be able to provide it during floods. My pipelines would be submerged, my pump would be submerged, my overhead tank would be submerged. I don't know what to do during the floods. Villagers say, no, we want it at all times. So that is how the rural dynamics work. That is how the demands are, and that is how the people are thirsty and hungry for water. That is how they demand their rights. And it's the duty of the Sarpanch, duty of the Gram Panchayat, duty of the water providing organization, just as if you are in Karnataka, then it would be RDPR, Rural Development and Panchayati Raj Department, which will provide water to you. If you are in Maharashtra, it would be Groundwater Survey and Development Agency and Jilha Parishad, which would be providing water to you. If I am in Madhya Pradesh, it would be Public Health Department. All those departments plus Sarpanch put together go to this extent to provide water to the villagers. And believe me, part of this discussion took place in front of me. Some of that is modified, some of that is refined, some of that, of course, I have added a bit. But most of the part of this discussion took place in front of me when we were having a Gram Panchayat meeting with that's called Gram Sabha. So having worked in Government of India, I had the privilege of touring entire India and getting to know how water is being provided in rural areas in various parts of the country, right from Nagaland to Tamil Nadu. So I've seen this, and it was my sometimes out of my interest, and sometimes it was my duty to attend the Gram Sabha that was being held to provide or to manage drinking water or other needs for the people of the village. So that is the definition. Sarpanch says, I will provide safe water for all your needs for 365 days in a year to 100% of the village at a convenient distance with equitable distribution at all times. Of course, the government is working for it. State governments, central governments, how much of it actually translates on the ground, I don't know. We don't know as such, because every village is different. Every scenario is different. The water resources are different. The availability is different. So there are a lot of issues with this, but the concrete definition for drinking water security is safe drinking water for all at all times. That is one sentence definition that we can define drinking water security. And when this is such an extensive and elaborate definition, we need to have at our disposal lot of resources, lot of planning, and how do we do it? National goal for drinking water supply says provide every rural person with adequate safe water for drinking, cooking, and other domestic basic needs on a sustainable basis. This basic requirement should meet minimum water quality standards and be readily and conveniently accessible at all times in all situations. So that is the national goal. But how do we go about it? And what are the key elements of drinking water security? Had it been an in-person meeting, a physical meeting, I would be taking all of your opinion that what do you mean by drinking water security? What are the key elements that you think comes into drinking water security? And when you say security, the immediate image that comes to our mind is a person holding a rifle and securing something. Security means that for us. But here security means assurance. In this case, security means assurance. So this assurance, how do you assure that everybody should get drinking water? Just as food security is very important for us, just as that drinking water security is very important for us. So what are the basic elements? What are the key elements? Let's see. I'll list it here. Let's find out. The key elements for drinking water security is adequacy, equity, accessibility, quality, sustainability, and usage. Because usage actually defines what kind of water you would be getting, how much water you would be getting, because usage is very important here. Adequacy, of course, is. Equity, of course, can be managed. Accessibility can be managed. usage is also to be managed. That is the and of course sustainability should be ensured. Adequacy depends on the availability of water, and at the same time it's a function of technical and administrative efficiency. How efficient our systems are. Equity requires technical efficiency. You need to lay pipelines and walls. A suitable pressure should be there in the pipeline so that it reaches everybody's house. So that is when equity is maintained. But political will is also required, because if Sarpanch is biased, which he should not be, any leader should be unbiased. If the Sarpanch is biased, that particular mohalla has not given him the votes, the particular section of the village has not given him the votes, and he would cut down the water supply to that particular village, that may not be good. So political will is also required. Okay, usage pattern influences the overall availability of the water, cross-cutting different sectors. We would see how those cross-cutting sectors are. Sustainability of sources, evidently, because if it is all times and in all conditions, the sources have to be sustainable, right? So how those sustainability measures can be built in. Accessibility is a great concern in rural areas. Just as it was being discussed that people have to walk miles, that is not the case right now for many villages now. Only few villages might be there in India who would have to walk miles, because everybody would be getting water very soon, and they have been getting water closer and closer to their doorstep. So accessibility, yes. Individual household connections should be there. Har Ghar Nal, Har Ghar Jal concept is there. Quality of the water, that's very important, because that is not only that doesn't only reflects in the kind of water that you drink, but sometimes the quality is so bad that you cannot drink it at all. So impure quality means no water actually. If you are supplying water with lesser quality parameters, then you are not supplying water, you are supplying something else that's just liquid, that's not fit for drinking. So quality, of course, is of paramount importance, definitely. So what is our status in terms of coverage? I mean, we say that we have got so much of water infrastructure available at the entire country, but this is the chart. When you see this, total number of habitations, number of quality affected habitations, number of partially covered, and number of fully covered. Those were old definitions, of course, but this is just to give you an idea where do we stand in terms of coverage. The graph looks very good, because if you are a good analyst, if you are a good statistician, or you got good analytical capability, you could see the total number of habitations are about this line, and just about say 10% or so are number of fully covered habitations. So about 90% is the coverage, or more than 90% is the coverage. Of course, there are some quality affected habitations, or some where equity is not available. So I mean, equity is not achieved. I mean, every person in the village is not getting water. That is partially covered habitation. That definition has been removed now from Government of India, but still that statistic is there. So number of fully covered habitations look very good to me. But when you add numbers to it, then it becomes, a big issue, And the number is, it is 17,25,576 habitations in all, and the fully covered habitations are 13,96,000. It's close to 14 lakhs. What does that mean? That means that close to 3,31,000 habitations are still to be covered. 3 lakh, and that is a big number. 3 lakh villages or 3 lakh habitations. Then it becomes a big issue. Then it becomes of prime concern that we still need to touch the lives of those people living in those 3 lakh habitations. The habitation is a particular section of the village. It may not be the entire village, but particular section of the village. So they are called habitations. So 3 lakh habitations are still to be touched. And that, of course, will be touched by the government in due course of time. The Government of India is working very well in that. But at the same time, we must understand that a lot of work is to be done. A lot of work is to be done by society also. Society means who? Society means geologists like me. Society means groundwater specialists. Society means geology students like you. Society means groundwater students like you. Society means colleges like you. And of course, the people of India. They need to understand. Now, the national coverage, if you see it source-wise, then you understand the importance of groundwater. See, groundwater-based habitations, again, a good statistician would immediately calculate the quadrant in which the groundwater-based habitations are. So 19 lakh habitations are based on groundwater. It's close to 84%. So 84% or 85% of the total habitations are covered with groundwater. Only 15% are covered with surface water. Surface water that is being brought from the rivers or the bigger rivers or smaller rivers. That is only 16%, but 84% it is groundwater. And what is the status of groundwater? Everybody's idea. The status of groundwater is okay in India. It's not very bad as it is perceived. But we will see why does it hit so hard? Why? Because you know there is a dynamic resource report by Central Groundwater Board, and in that report you would find that Delhi has the stage of groundwater development is 138%. Haryana has a development stage of 127%. Punjab has 170%. And your own state, Karnataka, has 68% of groundwater development. Uttar Pradesh has 72% of groundwater development. Now, how can it be more than 100%? Any groundwater development, how can it be more than 100%? This development is in terms of the natural recharge that is taking place. With that respect, the percentage is calculated. For example, 100 liter of water is recharged. If 100 liter of water is recharged, you are taking 136 liter in Delhi or 127 liter in Haryana. From where this excess 27 and 38 is coming? That excess is coming from the water which has been stored previously. So that is the ancestral water that we have. That's called ancestral water, the ancestral property. So that historical water that we have underground, that we are pumping out. We are recharging. I mean, the nature is recharging 100 liter. We are taking out 138. We are taking out 127. Karnataka is fortunate at the state level, at the entire state level. Karnataka is taking out 68%. So you are leaving 32% of your ancestral water. But that is not the case in Karnataka for every district. There are different areas, different districts in Karnataka itself. For example, Kolar district. There is a taluka called Mulubagal. Now, Mulubagal taluka in Kolar district, that was one of my project areas when I was with Government of India. And that had an extraordinary extraction percentage of more than 100%. So those kind of areas are still there in Karnataka. Those are the pockets of overexploitation. So groundwater, of course, is not there in all areas to support us in the quantity that we need. And at the same time, if you see the previous slide, 84% of our village are dependent on groundwater. So that is the situation. How does it get recharged? How will it get recharged? You know, the recharge is shown as recharge from other sources is shown in red. The recharge from rainfall is shown in blue. So if you see Karnataka somewhere, you would find that in Karnataka is here. In Karnataka, the recharge from other sources, of course, there's canals, etc. But 50%, more than 50% of recharge to groundwater comes from rainwater, more than 50%. So that is where the worrying sign is. And in UP, the recharge from rainfall is still higher. In other areas, like in other states, in Madhya Pradesh, etc., the recharge from rainfall is much higher than other things. So we are dependent on rainfall. We are dependent on rainfall for groundwater. We are dependent on rainfall for our crops. We are dependent on rainfall for a number of reasons, right? So we are dependent on rainfall for groundwater also. But how the rainfall is behaving? What is the total groundwater consumption? The total groundwater, if the total draft is 243 billion cubic meter, you would see that the irrigation is using around 221 billion cubic meter. This is just to see the things in perspective, just to set the tone of the discussion, that the irrigation is taking around 90% of your groundwater. Irrigation, agriculture. And we are talking about 10% here. It's 22 billion cubic meter, which is drinking water plus industries combined together. We're talking about this, but at the same time, we see that most of the groundwater is being withdrawn by which area, which sector. That is why I said usage is very important. Which sector? Irrigation sector. Agriculture sector is using a lot of water. Of course, the water cycle is there. We all understand it and we all know about it, especially the young kids who studied that in class 4th or class 5th even. I am of the old school. At my age, you know, when I was in PG, that time I first time read about water cycle in my post-graduation. I did not have the fortune to study it in my primary classes. But these days, these kids who are coming into post-graduation now, they've studied water cycle in their class 4th and 5th lessons. So that's very simple. The water evaporates, clouds are formed, water comes back to earth, and the water comes back to sea. But in between, something happens. That is groundwater, percolation of surface water to groundwater. That is groundwater recharge. That is the natural recharge. That is the water cycle that we are accustomed to. That is the water cycle that has kept us, that has kept our planet, lively. Because that's the biggest desalination process, that the desalination plant that nature has provided us free of cost. Home doorstep delivery of clean water, doorstep delivery of sweet water to you by way of rains from the distant sea, right? And that's absolutely free. But is it going to be the same? Will it remain the same forever? Will the water cycle continue to support us like this? What may be the possible factors that might impact this water cycle, which is bringing to you the water free of cost? Because that is the major portion which is refueling or replenishing your groundwater, rainwater. That is major part. So you need to be very much concerned about the water cycle and the climate. The changes in rate of transfer of water, the rate, because the water is being transferred from sea to your place. How this rate is changing. Then the temperature, of course, of the earth, that determines the rate also. Period of transfer, the duration. If you see the number of days for which the rains occur, the people who are living in coastal areas, they may not be aware that inland areas, the areas which are so far, so distant from the seas, they receive rainfall for about 50 days in a year. Though we call it a 3 months monsoon period or rainy cycle or rainy period or rainy season, the number of days on which it rains, a particular number of days, are limited, very limited, 50, 54, 45, 30. How many days does it rain in Delhi? If you ask some Delhi wala, he would not remember it. In Delhi, it rains only 16 days per year, sir. 16 days. So that is what we need to be aware of, that our days of rains are numbered. So period of transfer, the duration is also very important. And of course, the climate change, which we are all worried about. So these are the factors which is going to change the water cycle, and that is going to change the way we receive rains, and that is what is going to affect our groundwater reserves. What is the evidence of climate change? Is there an evidence? Yes, the climate change is happening. How can you say? This is a scene from a typical Ice Age movie, Ice Age 3 or Ice Age 2, I don't know. Ice Age 3 probably. I've seen all that. So you must see it. The kids who are watching this, or even the seniors, those who are enjoying some time at home, they must see the Ice Age series. That gives you very good insight while giving you good entertainment. Ice Age. Okay. So the cyclone path Nisarga, the path that cyclone took in 2020, that's an evidence of climate change. Earlier, the cyclones which were originated in Arabian Sea, they used to travel towards Gulf of Oman, like this, the red dotted line. Last year, the cyclone changed its path and came to the inland areas of India. The cyclone's impact was observed as deep as Madhya Pradesh, because the cyclone could travel that deep into the Indian subcontinent. You know why? Because those Indian subcontinent areas were hotter than the Middle East. So the cyclone took that path. And to tell you, on one particular day in 2019, one of the towns of my own state, Badwani, was the hottest place on earth on that particular day. Can you believe it? Hottest place on earth. That was on that particular day, Badwani, a town in my state, was the hottest place on earth. Just imagine. So that is why we see the climate is changing. Of course, the climate has changed number of times in the geological history. Those who are students of geology, they will know it. But of course, for the survival of human race, we have been so dependent on rain, so dependent on this climate which we have evolved with, that is just a minor shift would set our life on turmoil, right? So vulnerability, why India will be affected by climate change, why it will be affected, and how it would effect in groundwater and ultimately into drinking water security that needs to be understood. So why India will be affected by climate change? Because we are dependent on rainfall. The term Varsha, you know, Varsha is a Hindi word or Sanskrit word. Varsha is so important that the term Varsh that you hear in the Hindi term for year, Varsh is defined by Varsha. So if you go to any rural area, whether it's Karnataka or Maharashtra or Uttar Pradesh or Nagaland, you would find the discussion centered around the rains. How was the rain in your area? The businessman would say, no, sir, the rain was not good, so business would not be good. The farmers would say the rain was not good, so the crops will not be good. If the rains are good, everybody would be happy. So our dependence on rainfall is well known, and that is why we are so vulnerable. Our dependence on glacial rivers is also well known. So we are vulnerable to, you know, the temperatures of the warming up of Indian subcontinent. The evidence we have seen by the path that Nisarga took. So the evidence is there that we are warming up, we are hotting up, right? And the normal annual rainfall distribution that we have. If you would draw a line from north of India to south of India, you would find that the entire western India, entire portion to the screen's left is not having very good rainfall, while the right side, the eastern part of India, is receiving good rainfall. So that is the normal annual rainfall distribution, and that is going to impact us and our villagers and the drinking water sector into a lot of trouble if the rainfalls are not good. Okay, coming back to groundwater, we are so much of groundwater based that we are internationally known as groundwater economy. Do you know that? India is called as groundwater economy. We are the biggest consumer of groundwater. You know, we consume groundwater equal to the sum of groundwater used by US and China put together. So we use at around 26,000 crore liter, which is double China, double US. So that is what is our groundwater usage. We use a lot of groundwater, and we use 25% of the total groundwater usage of the world. 25%, 1/4 of the water, while we have only 4% of the groundwater reserves of the world, and we use 25%. That is more than 6 times of our allocation. If you see it allocated like that, if you got 4%, you can use 4%, but you use 25% of the total groundwater usage. So we need to think about where our groundwater is being used, where it's going. And groundwater use, 54% of India faces high to extremely high. Again, the same vertical line would divide Western and Eastern India, and you would find that the Western India is facing more of water stress. And you would see the groundwater use again here. Irrigation, 89%, domestic use, 9%, industrial use, 2%. And all the time, we say something for putting a restriction on groundwater use by industries. They are using only 2%, sir. And the industry is using 89%. We need to think about it. We need to think about our priorities. We don't say that you don't use groundwater for irrigation. Of course, they are our, you know, they are our food providers. They provide us wheat or rice or whatever. But at the same time, we need to see things in perspective, that where our groundwater is going and how best can we manage groundwater. Can you manage groundwater by putting restrictions on industries which consume only 2% of groundwater? You cannot. Even if they reduce their groundwater demand by 50%, that will be only 1% reduction. Right? If you want to achieve drinking water security, you need to understand that this, if you can reduce this 89% to 80%, just a 9% reduction, and your drinking water availability is doubled, because that becomes 18%. So you need to do something in water use efficiency in the agriculture sector. Okay, this 54% is different 54%. We got so much of data in India that 54% of India's groundwater wells are depleting. That is a comparison of 2016 data, that 54% of water wells are giving a declining trend. The water level, aesthetic water level is declining. Okay, groundwater status in India. If you see again, the left and the right, I mean the western part of India is facing acute groundwater problems, and we are in a vicious circle. If you see the rainfall pattern, the rainfall is happening lesser and lesser in Western India. And the lesser rainfall in Western India means more groundwater extraction. But at the same time, lesser rainfall means lesser of, groundwater replenishment. So that is a vicious circle. Less recharge, more extraction of groundwater in Western India. That is where we are very precariously placed, and we need to understand that how can we manage groundwater. There are different signs also. The agroclimatic classification, if you get down to the district level, it is shifting. It is the shift. Arid to semi-arid, arid to dry subhumid, arid to moist subhumid, semi-arid to arid also. That is the shift that has been recorded. Total area with climate shift is 27.3%. In this total area, if you go to microzonation at the district level, this climatic classification at district level was determined by Central Research Institute for Dryland Agriculture. So that is a phenomenal thing which is happening in India, and we need to be very much concerned about the west and the east. In Western India, you would find the shift is more, the climate shift is more. We are getting it. And the particular graph that you see, the food production is going to get lesser if the temperature rise. As little as 0.5 to 1.5 degrees centigrade increase, and 2 to 5% crop production would decline. For greater warmings, if you increase the temperature further, there might be a depletion of 25% in the cereal production. The entire Southeast Asia, it is 4 to 10%. For India, it is 25%, maybe. So that is where, and the surface temperature, if you observe the historical surface temperature that has already happened, you would see that the surface temperature of India is increasing since last 50 years. It's increasing. It's on the increase. So that is the climate shift that we have. Water resources of India, of course, average temperatures will increase by 5.44% in South Asia. Dry season rainfall, we're talking of rainfall. Dry season rainfall that we often experience will drop by 6 to 16%. And wet season rainfall will increase by 10 to 31%. So wet season rainfall will bring you floods in the rural areas. Dry season rainfall, which used to support our water resources for controlling evaporation, they would be lesser and lesser. So that is the climate shift that we are talking about. Such shift in temperature and precipitation patterns could carry major repercussions for India's fresh water resources and food productions. In addition to the implications for drinking water and sanitation, this could considerably diminish crop yields also in the region. The Gangotri glacier is on the retreat, as you see here. Gangotri glacier is melting. So the glacial reverse dependence that we have in the northern India would also be in danger. So glacial rivers would also be decreasing their flow because of the fast melting of glacier, and ultimately maybe very much reduced flow that they have. Okay, so what the situation we are in? Sources are groundwater based, replenishment is through rainfall. Rainfall is getting lesser and erratic. A major chunk of our water use is going into non-drinking activities like agriculture. Of course, agriculture is important, I again say, but the the proportionate distribution of groundwater for agriculture worries me actually. Okay, drinking water, what can be done? Drinking water security through enhanced source sustainability. Whatever the source is there should be sustainable, and through integrated water resource management and participatory approach. That is where sociology comes in. That is where psychology comes in. And when you're working in rural India, you cannot work without social dynamics. You cannot work without psychology of the people. You cannot work without social activation and social mobilization. That is the bigger lesson for the groundwater managers of the country. That is a bigger lesson for the groundwater students of the country. That if you are studying groundwater, don't be in an isolated patch. Try to think of groundwater applications for various sections of society. How do they perceive groundwater? Try to think of those terms. So that is a lesson for groundwater students like me also. I'm still studying groundwater. You're also studying groundwater. Number of people in you are studying groundwater and geology. How best can you be of help to the society? Just think about it. And you have to study a lot when you have to study drinking water security. You have to study the climate, geology, hydrogeology, of course. Then you have to study about competitive users like agriculture, industries, other businesses, operation and maintenance of the pipe water supply schemes, contamination, because quality is of major concern, demographics, how the village is expanding, how people are setting up, what are the settlement patterns of a particular village, and the infrastructure that you have. So number of things that you have to study, and of course, where do you want the drinking water security to be achieved? What may be the unit of measurement? Because there is a very famous saying, and that is the crux of drinking water security of any natural resource management. You cannot manage what you cannot measure. You have to first be able to measure it, and then you can manage it. So you have to measure, and then you have to manage. So first of all, you need to have some kind of management. You have some kind of measurement. What level you want to measure it? Gram Panchayat or watersheds and micro watersheds. They are the levels. What is a watershed? Of course, we all, or some of us may know, but we need to study it a bit more. Those who don't know, that's a homework for them. And those who know, just give it an idea. What's a watershed? Okay. So various Gram Panchayats situated in a given watershed, we'll have to group together. That is the idea. That is the idea that the watershed can be isolated, but still when you come to the watershed, there might be number of villages or number of Gram Panchayats sharing a particular watershed, and you can manage all those in a micro watershed. There might be a number of Gram Panchayats. So you have to combine, you have to put together all those Gram Panchayats, develop a strategy. And I'm telling you this because the groundwater manager cannot think of just aquifers. The groundwater manager cannot just think of geology or granites or basalts or sedimentaries or metamorphics. You have to think of the settlement patterns, because the people who are going to be benefited by you, they live there. They live there on the surface of the earth in those watersheds. So if you're living in these watersheds, then you have to think of how they are living, how they are disposed, how they are placed, how those villages are placed. So you have to think about that. You have to think about the watershed. You have to think about their administrative boundaries also. So if you're a groundwater geologist, if you're a core groundwater geologist, then of course there is another area for you to work, aquifer as units. You can take aquifer as units for drinking water security. That okay, we will treat this particular aquifer for drinking water security, and we will recharge this particular aquifer for drinking water security. But again, mind you, that may not be the ultimate solution. The ultimate solution lies in the minds of people, the sociology, the social dynamics of the people. Aquifers have been managed since long in the world, but they have not brought the result to that extent. You need to put in sociology there. You have to identify the area, you have to make some institutional arrangements, you have to have baseline data collection. I'm giving you a kind of research approach here. You need to go into water budgeting. You have to have a budget for every village, and then you have to identify the key issues. What is happening? Whether the leakages are more, whether the village is spending much groundwater on agriculture. Can they reduce their dependence on groundwater in agriculture and improve the drinking water security of the village, as we discussed? That is all in the approach, and ultimately the implementation of your ideas. So you have to work at the village level for village water security. You have to work at the village level for drinking water security. Even if you are a groundwater geologist, a core groundwater scientist, you have to apply your science here. Okay. Government setup should remain in the background. You know why? Because why? I have highlighted why here. Because it is the people's revolution kind of thing. The people are going to manage the groundwater, and that has already happened in a number of places in India. You must read about AP farms. Andhra Pradesh farmer managed groundwater system. 700 villages manage their own groundwater in Andhra Pradesh. So they can be one of the good examples that you have. Then of course you got an example of Hivre Bazaar in Maharashtra, and of course Raleigh city is lot talked about, but Hivre Bazaar, the Popatrao Pawar is the main person there. You should read about Hivre Bazaar. That's all the homework that I'm giving to you. Hivre Bazaar, AP Farms, and Raleigh city, they are the wonderful areas where you can see participatory groundwater management. Of course, you have to start with sensitization. You have to start with something good activity in the social platform, on the social platform of the village. You have to perform. You have to bring people to your ideas. And the best thing to bring people to your ideas is music or parties or whatever. I mean, in whatever way the people can enjoy, and then you float your ideas. You ask for the volunteers. You recruit volunteers. Can you find out what this rural woman is doing here? You know what she is doing? She is measuring rain. Measuring rainfall is no rocket science. While we had very few rainfall measuring stations in India previously, we should have more of them, because the rain gauge station is not a big deal. You can measure your own rainfall. As I said, you cannot manage what you cannot measure. You have to measure the rainfall, because there are a number of areas in a particular watershed which are in rain shadow areas. Rain shadow areas where the rains are not happening, while the other areas, the watershed is receiving the rainfall. You should know what rains are happening in your own village. You can put up a rainwater station, rain gauge station in your own village. Okay, you can have these kind of discussions with the volunteers. Okay, and you can actually prepare the water budget for your village. This is a particular Gram Panchayat meeting in village Chada in Mehsana district of Gujarat. That is one of our first projects for drinking water security. The people there gathered, they put up, they made all the observations, and the Central Groundwater Board officers and our officers of our ministry in Government of India, the Gujarat Water Supply and Sewerage Board officers, they were also there, and they were all sitting in the background. And they told us that, sir, why are we sitting in the background? I said, let them work out and let us see their result. And you would be surprised, you would be pleased also that their result was very much similar to what Central Groundwater Board results were there. So whatever measurements Central Groundwater Board did, whatever analysis they did, whatever percentage of groundwater withdrawal they predicted for the village people came very, very close to it. Very, very close to it. That is because, you know, they have got an inherent capacity of learning about resources. And then they proudly presented their results to us, and we were all so overjoyed that they could work out their own measurements of groundwater. That's called water budgeting. We can have a wonderful discussion on this, a longer discussion on water budgeting, but that takes another 2 hours maybe. Okay, so I'll just give you an example how the groundwater is being managed for drinking water security. How should it be managed for drinking water security? You need people, you need participatory management. Unless and until you do that, all your theories and all your sciences would remain, you know, in the background. They would not be put to use. They would be put to use only if you say to them that you do it yourself, you find out how much water is being used, and then you try to reduce your own water requirements. Very simple instruments, very simple, you know, buckets and drums measurements. Of course, this is only the technical tool that we use there. The only technical tool, that is the groundwater logger, or water level recorder, by which we can use you can know the groundwater level in a particular well. That is the only technical tool. Otherwise, everything was there available in the village itself. We measured it through a simple stopwatch. We measured it through simple water meters and a simple log like this would be enough. So that is how number of stories on groundwater, number of stories on drinking water security, number of studies and stories on water budgeting. These people who are considered, you know, kind of illiterate, those people who are considered backward, those people whom we try to go and educate. We can learn so much from them because they are in close proximity with the nature. They've been using the resource for which we are advocating. They are the users, so they know more about it than us. Of course, they may not be that scientific in their approach, but the science is our domain. Their domain is the field knowledge. Of course, so that's all. And you know what decisions they took? We left them to take their own decisions. And the airport, the Gandhinagar, the Ahmedabad airport was about 2 hours distance from that particular village. We left for the airport. I left for the airport and left to them. And within 2 hours, they could reach a conclusion that they have to close all leaks, replace pipes as required, repair or change pumps, improve sanitation and drainage, coordinate with electricity, agriculture, forest and other departments, and support improved tariff collection for their drinking water security. So that is how the groundwater should be managed for drinking water security with the participatory approach. You need to understand that these are the people who are going to be working there in your absence. A groundwater geologist cannot be there for all this, of course, and drinking water security cannot be achieved just by this. You need to have a proper understanding of how groundwater is being. Here it's a South Indian village, AP Farms picture it is. the ladies are learning how to use the water logger, I mean the water level recorder. This is how they measure their water in AP farms. They got this typical measurement. If you got 1200 mm rainfall, they would go for banana and sugarcane. If they got 600 mm of rainfall, they would go for sunflower and these kind of orchards. If still lower, if it is only 300, they would go for these kind of crops. Some crops which would require less water. So this is all about, you know, water management by your own measurements. You need to, and yes, you have to put a big lock on these drilling machines. Unless and until very much required, you don't have to go for more exploitation of groundwater. You have to put a big lock. Whatever resources we have exploited them enough. You need to understand that we have to live with whatever resources we have now. So you need to go to this picture again and understand, based on the rainfall, you can reduce or higher, or you can lower or higher your crop requirements or crop water requirements. And based on that, you can choose your crops. That is how we need to understand. Okay, so this is again the pictures of AP farms, and they are showing how the water balance is there in their own villages, and they are explaining these are all normal people. These are all village people. There's those who are understanding it. So there's a participatory approach, and then of course expanding these activities from one particular village to the federation. Identify representatives from the Gram Panchayat, and then you can put together a pool, and then that is where the sociology works. Identify areas of common concern, bring a federation, form a federation of villages, and then you can work for it. Identify common rules and regulations of water management, develop on a long-term combined development management plan, and the elected representatives of government to support the plan that you are proposing. That is how. Of course, coming back to the geology part of it, because geologist has to play a very vital role. You can map out different areas on your satellite imageries. What kind of geomorphology you have? Where is the habitation? The habitation is here. Where is the buried pediplane under granite, over granitic niches, which can provide you good shallow water? Where is the pediplane of granite niches, which may not be giving you much of water? Where is the fracture zone, which will be giving you more water? So all these things can be analyzed on a satellite imagery. All these things can be mapped on a particular groundwater prospect map, and then you can actually support the village people by telling them that everybody everywhere you cannot get groundwater. Groundwater is located in certain areas from where you can extract it. Groundwater is located in certain areas where you can recharge it. It's not everywhere. It's not possible to recharge groundwater everywhere and anywhere. That is what you need to understand. And then you have to basically work for the habitation. So that is the idea. Again, this is another satellite imagery where you can find how soils are moving, how soils are placed rather, what kind of soil we have in different areas. And this is of course a part of Maharashtra, Parali village, and where you can put up contour trenching, where you can put up gully plugs, where you can put up contour trenching with vegetation. All those areas can be supported by you, by you being a groundwater geologist and you being a specialist in remote sensing studies or satellite imagery studies and their interpretations. You can actually support them by these. But ultimately, the people there, they have to be sensitized, and they need to have a sensitization of their, rights as well as duties as well as responsibilities. This, of course, is from Uttar Pradesh, one of my project areas, where we identified a particular lineament, and which was a very high producing groundwater area. So we need to understand that these are the villages or where you can get groundwater, and how can they get groundwater from different areas so that they can provide water to other villages also. That is how this was conceptualized. These are the different watersheds in which different panchayats are there. So different watersheds, different panchayats. That is how you need to understand. That is how you need to provide drinking water security, through managing different watersheds, through managing different ground areas. This is not enough for a 40-minute or 1-hour lecture. This is all the work that I have done over a period of long years. Of course, that I applied that for a period of 3 years while I was in the Government of India. But otherwise, this is a work which we have done since last 20 years or more than that. So this all requires a lot of planning, a lot of implementation, a lot of ideas. But this is just to give you a brief idea of how a particular habitation in a particular watershed can be drinking water secure. We can provide them where the sustainability structures can be, where the groundwater can be extracted, where is the best possible area from where you can recharge, to which you can recharge, and from where you can extract. This is all the job of a groundwater geologist. But at the same time, you need to understand the psyche, the psychology of the people, the social dynamics of the village. I've seen worst cases. I've seen worst cases of casteism while you were using groundwater for drinking water. I've seen an open well, square open well of 4 sides. I said, normally the open wells are circular. Why do you make it 4 sides? They say, sir, this is 4 sides because we have got 4 castes in our villages and this is the only open well we have in a village. So all the 4 castes, they use different sides. The higher caste uses side A, the same open well. I've seen those areas. I've seen those differences. I've seen those population dynamics. The same open well having 4 areas for 4 different castes. Can you imagine that? But these are the stark realities of India, stark realities of everywhere in the world, maybe. So that is how we need to understand the world. That is how we need to change the world. And of course, somebody who can provide water can change the world. Somebody who can think of water can change the world. Okay, so enough of these talks, but these are the activities which you need to do for water budgeting and all. Okay, step-by-step development of various strategies that you can do. Okay, you can work on availability, you can work on quality, equity, usage, accessibility. And I end my talk with this brief story of my friend Bachu Singh from Madhya Pradesh. This Bachu Singh is a tribal, and we went to him to study the traditional knowledge documentation project that we have. And so we were there to study what kind of crops he grows. He grows some crops which are medicinal in nature. And those are snake bite remedies for the local people. This is my last slide. So Bachu Singh ji was there, and his name is Bachu Singh. He lives in Alirajpur district of Madhya Pradesh. And we saw him, we met him. He was very cheerful. And we visited his fields, and he said that he's got 4 acres of land, out of which he uses 2.5 acres for his own wheat and soybean, etc. 1.5 acres he develops the medicinal plants for snake bites and all. I said, why 2.5 acres only? He said, it is sufficient for me. 2.5 acres is sufficient for me. I saw no well, I saw no irrigation. I mean, I saw no source for irrigation in his entire field. So I started lecturing him, just as I am lecturing you today. So we have got a typical habit of, throwing our knowledge at others. So I tried to throw my knowledge at Bachu Singh. That, look, Mr. Bachu Singh, you got this 4 acres of land and you can drill a borewell here, you can put up an open well here, you can get more water, you can do this, you can do that with water, and you can multiply your crops and like that. He listened to me silently for about 10 minutes, just as you are listening to me for the last 40 minutes or 50 minutes. He listened to me silently for 10 minutes and then he took me to this place. Of course, I looked like this 10 years ago. Okay. So he took me to this place. This is an open well, which is only 1.5 meter deep. And this was about after 3 or 4 fields from his field. This was the Nala in which he dug a well. And that was dug when he was the Sarpanch of his village. And he did this on the last day of his Sarpanch tenure, so that nobody could say that he got his well dug first. This was under a government scheme. And he dug this well only at the cost of rupees 700. In 700, he dug this open well. He could locate where water is, and he could dug that well here. And then when I saw the water, I was astonished that, and I was at the same time, I felt a bit, insulted also that I got so much of knowledge and I was lecturing him and he could find out water by himself. And then he's using this water. So I tried to give something else to him. What we scientists call, value addition in our management terms. We call that value addition. So I tried to value add him. And I said to him, look here, Mr. Bachu Singh, how much is the water in this well? He said, sir, water is full. I said, okay, how much horsepower motor do you use here? He said, I use 2 horsepower motor, 2 HP. I said, yes, this is the point where I can give him some more gyan, And I said to him, well, Mr. Bachu Singh, you can put 4 horsepower or 5 horsepower motor here because the water is full. It's not getting any drawdown or something. Drawdown is a technical term. So I tried to impress him with the technical term. And of course, we are the people of market. So we believe in, giving more greed to the people. So I tried to bribe him that you can extract more water by installing 5 horsepower motor from this well, and at the same time establish my knowledge. What Bachu Singh ji said still rings here in my mind, and that's $1 million answer, $1 million, because we are habituated out of dollars and millions, so that's $1 million answer. There's crores of rupees of answer. You know what he said? He said that, sir, we take out from the jungle. Jungle is environment for them. Jungle, they call it jungle. We take only that much from jungle what is required. That was a fantastic answer. We take only that much. Otherwise, what use it is? If I put 5 horsepower motor, we take water which is not of any use to me. I said I was not to be defeated. The market never gets defeated. You know, we are from the market, basically. I am from the market as far as Bachu Singh is concerned. I tried to lure him further. I tried to offer him more greed. I said to him that, look here, Mr. Bachu Singh, you can grow more crops there, and you mentioned certain crops which require more water. So you can grow those crops of medicines which require more water there. So, I mean, this idea was good enough to be taken, but he was not to be defeated, sir. He was a true environmentalist. He took me to this site, and what he did, you know what? Those people who are familiar with water, those people who are familiar with rural nalas and rivers and smaller rivulets, they would know that there is an undercurrent flowing underneath the nala bed. So what he is doing is, he has planted those crops which require more water in this nala bed, so that those crops can utilize the water which is flowing beneath the top dried surface of the nala, and they can flourish. So he has done that. What he has done is, he has utilized that water which was flowing underground, and I mean undercurrent, under the bed of the nala, under the dried bed of nala. There was a water bed which is moving and which was of no use to anybody. What he did, in our scientific terms, he did not transfer the water from this place to that place. He reduced the energy which was required. He saved on that energy. He was not an engineer. He is not an engineer. He is not a geologist like me. He is not a groundwater geologist like me. He is not a, you know, big scientist like me or big scientist like anybody else. But he is a simple village man who can work with his brain and heart. Heart towards the nature, brain towards the resources. What he said, I again asked him, what prompts you to have such beautiful ideas? And what he said, sir, in his plain terms, can be translated in English like this: we prefer going to the water rather than making it come to you. Such a wonderful idea. You can give a clap for Bachu Singh. Bachu Singh, we need more Bachu Singh like that for drinking water security, for managing our resources, that you don't need to bring water to you. You need to go to water. You need to go to your resources. You cannot exploit your resources without brains. You have to use your brains when you are using the resources, and you have to use your heart when you are interacting with the nature. Thank you very much. We need more people like him. We need more people like you. God bless you. Thank you very much. Thank you, sir. Over to Dr. Pramod.
Yeah, sir. Thank you. Thank you very much. That was wonderful talk and awareness also for all of us. Shall we have some discussion? Any questions from audience?
Of course. I see the raised hand of Dr. Krishnamurthy.
Yeah. Unmute yourself, sir.
Sharma Saab,
Sir.
My heartiest congratulations to you. The best ever water lecture I have heard.
Thank you, sir.
And culminating with Mr. Bachu Singh's kind of fascinating intelligence.
Thank you, sir. Thank you, sir.
So that is a fantastic, information how our, villages can be improved with groundwater, which is the major source, which is the source, in fact, for whatever we do. I only wanted to have a doubt because next week, the Groundwater Survey and GSDA is celebrating its Diamond Jubilee. Maharashtra
Yes.
GSDA.
Groundwater Survey and Development Agency. Yes.
Yes, that is, and we are having as part of the, like what they did at Belgaum, we are having at Pune a meeting on 20th, and I am to speak on water conservation. So I did got a lot of education from your district. I only wanted, it was very clear. I don't think there are any doubts about it, because it is the village which is using 89% of agriculture for water and all. And that is where you clearly said, if we make some reduction, like the water commission mission use, sprinkler and other things, reduce your consumption. That you all well taken. I only wanted to know, I mean, I went to this site. They said India receives exclusively depends upon rainwater, and we get 4,000 cubic meters of rainwater. Is it a correct fact? 4,000 cubic meters.
India.
That is what it says. I don't know.
Sir, what you have to do is, you just have to, you just have to multiply the rains to the total geographical area of India, and you get the amount of rainfall that we get.
That is what, no, I think this may be a wrong figure, because it did give, so much rainfall we get. And obviously much is all going to during the rainy season. Rainwater harvesting has been the main part which can help us out. Because rainwater harvesting, again, it goes to the ground, again, groundwater. So it's very nice, sir. Thank you very much. I wish you carry on your mission, both scientifically and as a Rotarian. Thank you
very much. When Dr. Krishnamurthy, when you will be there at GSDA, you just impress another point on them.
Yes.
That we need to understand in India, as geologists, also as groundwater managers, also as technocrats and bureaucrats also, that everywhere groundwater recharging is not feasible, everywhere groundwater recharging is not possible. So how much area in India is there which is feasible for groundwater recharge? How much area is there? You need to understand that, you need to calculate that, and you need to focus your activities on that. So you need to understand that everywhere you cannot recharge, and that is why this misnomer that you have to put water everywhere into the ground is not correct.
Sure.
That can be embraced. I have been advocating this for since long. I have been talking about the groundwater recharge principles since long, and I have been telling Government of India that you have to focus your energy and time and money on the areas which are amenable for groundwater recharge.
Most suitable.
That makes sense actually. Correct. And everything should not be left to the people. There should be something which can be done by the government also.
Yeah.
So that needs to be done.
We need more Bachu Singhs.
Yes, absolutely, and there are.
Yes.
Sir, there are so many people. Otherwise, how do you think we are surviving, sir? We are surviving solely on basis of such people.
Definitely. Thank you.
Yes.
Sir, we have a question from Saukar, sir.
Yes, sir. Yes, Saukar, sir.
You see, I appreciate the lecture that is given, particularly with reference to the use of water in agriculture, which amounts to 89 to 90%. The only way to reduce that is to price the water for different crops. We have been telling that we should encourage the cropping pattern which use less water and all that. We can buy a sugar at 25 kg, at rupees 25 a kg sugar, but we can't buy a pulses for 80 to 100 rupees. You see, although pulses are very good for health and all that. You see, like that, if you use a ragi crop versus a sugar cane or a paddy, whatever is the excess water that is used by paddy or a sugar cane, that amount of water cost should be given to a ragi grower so that he will grow a ragi. But the problem arises, they asked me, you see, they will stop growing sugarcane, they will stop growing other things. But if you grow more ragi, where are you going to store it? Where are you going to market it? These are some of the problems which we face in actual scenario and all that. In any case, we feel that water should be priced while cropping patterns are being made. Nowadays, you know, they are developing so many advanced technologies like aquaponics and all that, where they use less water and produce more crops and all that. These require a high capital and also technology, which ordinary our village people cannot use it now. But given a proper training, they should be able to use this. So it is a big science, as the lecturer has told. And what I want to remind is, I saw one village near Pune, about 150 kilometers away, developed by Krishna cult, where they had developed a water treatment plant. The water treatment plant was such that the input water, and after using on domestic purposes, drinking water and all that, the output that goes into the river is the same. So that type of water treatment plant for about 1,000 people would cost about 1 crore of rupees. So if you calculate according to the lecturers what he said, 14 lakhs habitants and all that, we don't know what is the total capital that is required to make safe drinking water to villages. So these are a major problem which we have to set. Another thing is that Singh, what he said was, instead of water bringing to us, we go to the water. But the government of India is thinking the reverse way. They are taking water to the pipeline to every village, every house. This is the analogy what we find from the present system and all that. But it takes, as he said, a social change to thinking over in this water. I want to make another statement, you know. This John F. Kennedy was the president of USA, said that anybody who can solve the problem of water will be worth 2 Nobel Prizes, one for peace and another for science of water. Peace, of course, as you know, we are fighting every day for the water sharing. Even in our own basins in Peninsula River or even in any other river, we say that we want more water, we want more water. So international field also, they say our river should get more water. So ultimately it will lead to a war. You see, and another thing is we have not understood the science of water. So the science of water also has to be understood. So if you solve this problem of water, you will be eligible for 2 Nobel Prizes, as Kennedy had said. I think we must think over this line. I'm very glad Professor Ramangoud has organized this as a first event in his regional center for opening and all that. I do hope many other centers will be opened in India on behalf of the Geological Society of India. As a matter of Geological Society of India has produced very large number of literature on groundwater and all this, on water and all these things. And as a matter of fact, you know, Sahyadri Hill Range gives rise to both east flowing river as well as west flowing river. If we utilize properly, arrest water in proper places, the peninsula itself will become a water surplus area. These are all proven by statistics in our own Geological Society publications and all that. I thank Dr. Ramangoud for organizing this lecture through a very well learned Rotarian. You see, he has got a social context. He can see what the social feeling is on water. Thank you very much.
Thank you, sir. Thank you.
Sir, were you to Jan recently? Did we meet somewhere?
Pardon?
Did you visit Ujjain recently? Did you visit Ujjain 2 years back?
Yeah, I did.
We met there, sir. We met there.
Yeah.
If you remember, we met there at the Shipra Jagrati Sammelan or something.
Yeah. I know.
I am a disciple of Dr. Rajendra Singh.
Yeah, you know, you see that area in Maharashtra where he has developed that not even one drop of water goes outside his basin and all that.
So we met there because of
you see the adjacent hill, that is all dry. It is all developed by forest department. Is it?
So Saukar sir, thank you very much for your wonderful comments, and of course Dr. Rajendra Singh ji would be the first contender for the Nobel Prizes, both the Nobel Prizes.
Yeah, I have already recommended. I have been telling him This quotation I have been telling him from the beginning.
I've been telling him not to go to Stockholm before he receives Nobel Prize.
Yeah, I told him, you see, Mahatma Gandhi.
Thank you very much, sir. I could recognize you by your name, and I could remember that you were there.
I told Rajendra Singh.
Yeah, in the
I told
Shikra
Rajendra Singh, Mahatma Gandhi held.
Thank you very much, sir. Thanks a lot.
Mahatma Gandhi held one fist of this salt and shake the whole British government. So you take the water and shake the whole government. This is what I have been telling him.
Sir, may not be required because we are independent now. We have got our own government, of course.
Yeah.
Okay. Thank you very much, sir. Thanks a lot.
We
can have other. Yes. Thank you, sir. We can have other questions from Ameya Kulkarni and Dayanandji, if they are.
Yeah. Malkai, sir.
I am here. Hello, sir.
Yes, sir.
Yeah. Your topic was regarding this groundwater management and especially concerned with the water supply schemes. Am I right?
Yeah.
So, I wanted to know, because so many water supply schemes are, rather the water sources are depleting. So they need to be resupplied, redeveloped. So in this matter, have you taken up any programs or any projects, and so that we will get some idea to
Number of. Yes, Dayanandji, number of.
Please.
In fact, in fact, when you say supply, you know that you cannot achieve drinking water security just by supply side management. You cannot. If there are, say, about 100 people in a room and I put 200 bottles of water to them, some of them would be utilized, some of them would not be utilized, they might be thrown away, and then they would demand more. So the supply side management should not be the focus. The focus should be on the demand side. So the entire concept of drinking water security works on demand side management. We need to understand how the demand is, what kind of water usage pattern we have. If we can manage the demand, then of course the security can be managed. Otherwise, all these structures like rainwater harvesting structures or groundwater recharge systems, or even the pipe water supply schemes, they are all supply side management. Of course, we need to take care of them. But government has done so much for supply side. Even after that, if the people are not getting water, there must be something wrong. And the wrong is, you have to have a demand side management. You have to have a sustainable source. You work on sustainability of sources. To your surprise, sir, Government of India provides 100% sustainability funds. Whatever the state demands, the Government of India provides sustainability activities funds. 100% funded. But still, the surprise is this, that still the states are not able to utilize them fully. That is, we need to focus more on sustainability, as you rightly said, that the sources must be sustainable. Yes, we discussed that. And of course, in the 40-minute lecture, we cannot do more than that. So what we have done is, we can discuss sustainability at length. We can discuss sustainability for years, for days together. So that is, in a nutshell, sustainability is very much required. Sustainability of sources, whatever source you have, whether you are taking water from a river, we are taking water from groundwater, sustainability is very much required.
Population is increasing, and demand for utilities is increasing.
Absolutely, sir. Population is going to increase. The settlement patterns are going to change. We are here to tackle all those problems. Definitely. That is why.
Accordingly, the project has to be projected in that way.
Sir, all the projects are based on LCA, life cycle approach. So this life cycle approach is there, and all the projects of all the governments, they basically envisage at least one generation of 30 years. Thank you very much, sir. We can go to.
Yeah.
Thank you very much.
Sir. Yes, sir. Anil Gudi, sir.
Yeah.
Or Ame, whatever. Whosoever comes in first.
Yeah.
Anil Gudi, you're right, Rotel and Sudhindra. Your talk has been fabulous, very informative. And I should thank Pramod for having invited me also.
Thank you, sir.
Now, I've just made a mention in one of the in the attachments of the chat. I've been writing a little on this since the rivers are getting dry through years. I thought check dams in every river and a tributary. Tributaries also are pretty big of all our rivers here throughout. If we have check dams, automatically, I think the subsoil water level itself will increase, which has depleted to even 200 feet, as low as 200 feet in some places. This, I think, in a matter of about 3 to 4 years, the groundwater level will increase. So today, if we say agriculture is using, say 89 or 90%, whatever is there, now that is probably in comparison with the water storage, whatever is there underground now at the moment. Agriculture definitely will require more water, acceptable. But as you already rightly put in your talk also, with controls put on all this water, the consumptions for every agriculture, we can bring a control on that. But I thought rivers and these are dammed with check dams and bigger dams also. The base of water level itself will increase throughout our country. We have n number of rivers, and if that increases, I think to an extent our water level, I mean, water problem will be sorted out. That's what I feel personally. Secondly, I was just wanting to know from your side, you know, as Rotary had taken a program of polio eradications in 1980, and today we have eradicated to near 0%. Can Rotary India, with under the realm of our Shekhar Mehta as the RI president, can we Rotarians join hands and really try and convince and talk with the government and see that the government takes some positive actions as applying our four-way test itself? Can we do something on that line? Because we keep talking, but I mean, it's becoming difficult with no ends meeting. That's all. That's all.
Rotarian Anilji, thank you very much for that wonderful suggestion, wonderful question also. And you put a can there. Can Rotary India do this? So of course Rotary India can do that. But when you try to make an analogy with the polio eradication program, you would find that what was the most important aspect of polio? The most important aspect of polio eradication program was Rotary's leadership. Yet the most important aspect was community participation. So I rest my case again on community participation. You need to have various agencies working for community participation, bringing them up, and polio eradication program was successful because the problem was homogeneous. Here, the problem of water is not homogeneous; it's heterogeneous. It is different from. I mean, Nagaland water problem is different than Tamil Nadu. Rajasthan water problem is different than Bhubaneswar. You know, so all these problems are different, and therefore the site-to-site variation, site-specific suggestions, site-specific projects, site-specific ideas, they are required. And they require a huge technical support from Government of India. Huge technical support.
Right.
And I say Government of India. Why I say Government of India? Why not government? Why not state government? I say Government of India because when you are at Government of India, you see the whole country in perspective. Right. That is where Government of India need to come in, and you should and we should remember that when polio eradication program was running across the world, all the governments were participating in it. So when we can think of something which is more focused on water provision or water availability, then of course we can work on that. A long-term water management plan can be drawn by us. The Rotarians are there. Vasrag is there. Water Sanitation Rotary Action Group is there. Right. We can do that. Yeah. But for implementation, we need community participation and participatory management. That is a must.
No, I agree.
As you rightly said about rivers, in the rivers, it's a mix of various parameters. When a river dries up, it's not only because of lack of water, it's not only because of lack of rainfall, it's because of the lack of soil profile also, it's because of lack of vegetation also, vegetation which holds the soil profile. And then the groundwater is not immediately beneath the soil. That we need to understand there is a disconnect somewhere in hard rock areas. There is a disconnect between the soil profile and the groundwater. And that whole sheet of impervious rocks is there. So number of places you would find the river is dry, but the down below groundwater is available after the soil surface, in the ground, in the rock layer. Right. So that is there. And the reverse is also true. Groundwater may not be there at all, but the rivers are flowing because the rivers cannot recharge the groundwater directly. So these are various complex situations with complex hydrology that need to be studied at the complex level and then should be simplified. Just as we said, demystification of science. We need to demystify hydrology for the villages.
Okay. Fine.
Yes, sir. Thank you.
Just one. Shall I just continue for just a moment?
Yes, sure, Anil.
If our rotary is spread throughout the cross section of our country. Okay.
Our rotary
it's throughout the cross section of our country. Every state has rotary.
Yes.
Rotarians are there. Now, Rotarians also are in line with a lot of NGOs also.
Absolutely, yes.
Who are positive thinkers also, who are in the same line of our own thinking. If we have some sort of a brainstorming among ourselves, sitting together from all the various corners, study all their problems, whichever in the nook of corner of our country, try and sort out all these problems according to their requirements. But there should be some common thinking people who should come together, flock together, and work on this program, thinking it that this is going to be our program for next 20 years, and we see that our problems are sorted out. If we do it, I think we should be able to do it. That's what I thought.
Yes, Anilji and rest of the participants, just give me half a minute to talk on this. There are two approaches. One is that Dr. Rajendra Singh has adopted, that you start working wherever you are. You start working wherever you are, and then you spread your word, spread your technology, spread your thoughts, spread your approach. Because the approach is very important. So Rotarians have to start wherever they are. Whether we get a good big federation or not, we can start wherever we are. So that is one approach. Second, and the bigger thing in this whole thing is we need to have a very good training approach for all the Rotarians. We need to have a very good training infrastructure or training approach for all the Rotarians on water. So I would ask Shekhar Mehta ji, whenever I meet him next, because I keep on meeting him on various platforms and Zoom and even in person also. I am on their Rotary India Water Conservation Trust also. I am on their Rotary India Water Mission also. So and I'm just fortunate that he recognizes me personally. Okay. So I'll talk to him about training of Rotarians on water. That is very much required. RIWCT, RI Water Conservation Trust is doing. Rotary India Water Conservation Trust is doing great work, and we will keep on meeting Anilji. Thank you very much, sir.
Because Rotary focuses on nature itself.
Sure.
Thank you very much.
Pramod, in fact, thanks to Pramod. Of course, he's the key person here who has connected us all together.
I know. Thank you very much, everybody.
So okay, Pramod, can we take questions from Amey and Dalchan?
Yeah, Amey and Dalchan.
Sir,
yes,
Amey. Sir, I'm a BSc final student from GSS College. Sir, I just wanted to ask you that completely as utilizing groundwater as the primary resource, can we make it a secondary and proper management of surface water resources and recycling the used water, that is seepage water and other industrial water, and then whatever the remaining amount of demand we have, and that can be then supported from the groundwater, because even recharging of groundwater is also a major issue in this scarcity of rainfall season. Because sir, I would like to highlight one point, sir, because I belong to Sangli in Maharashtra. I have been because of my father's transfer, I have been shifted to Belgaum. Sir, in Sangli, Krishna River flows in the middle of the city. Despite of this river, and from Sangli within a distance of 20 kilometers, there is a sangam of Panchganga River with again Krishna. Despite of this water resources, in each and every house of Sangli, unfortunately, they have a bore well of up to deep of 300 feet, and which is very, very hard water. So this improper management of surface water is also should be improved. This is my thought. So what will be your insights on this?
Amey, you are the BSc final year student?
Yes, sir. And I am a retractor too, sir.
Retractor also? Yes.
Yes, sir. In GSS college only.
And you are studying geology?
Yes, sir. Yes.
Okay, wonderful. You are on the right track.
I'm student of Hanamad, sir. On this, sir.
You are on the right track. You are in wonderful hands with Dr. Pramod and other faculties of geology there, and you are on very right path. What you are talking about is called conjunctive use of surface and groundwater. So that thought is already there, and we use conjunctively the ground and surface water. And of course, groundwater is not the primary source of water in number of areas. The primary source of water is surface water in number of areas across the country. You rightly said, but groundwater is available at point of use. Wherever you need water, groundwater is there. So when the groundwater is available at point of use, it becomes the primary source. But at the same time, you need a national grid, you need a national plan to make surface water as the primary source. As far as river supply is concerned, that needs a lot of infrastructure, and that needs a lot of willpower that I addressed in my presentation also, that you need a lot of political willpower also for that. And that needs a lot of funds, lot of planning also. So one has to be, very much cost conscious also, that how much cost would be required to bring that surface water to your doorstep. So that needs to be done, and you need to analyze how much is the ROI, return on investment, in that particular project. So good thought. Keep on thinking. That is the crux actually. You need to think. You need to ask yourself certain questions. You need to ask your faculties certain questions. You need to ask your juniors also some questions, and you need to ask the people of this country some questions. Then only you will be improving yourself. Definitely. All the best to you, Amey. Thank you very much. Wonderful questions. Thank you. Yes, Dalchan ji.
Good afternoon, everyone. I'm DC Jharia from Raipur, Chhattisgarh. Thank you very much, sir.
Oh, you're from Chhattisgarh. Great.
Yeah, yes. And thank you very much, sir, for very informative and inspiring lecture also, sir. I feel, sir, this is the real study you are doing, sir, towards resolving water-related issues, sir. Sir,
thank you.
That if we want to further explore that subject, like rural, that groundwater study, is there any sort of manual or any guideline are there?
Yes, there are. One manual has been written by me only. You can search for Manual of Sustainability. Yes. That was written by me, Manual of Sustainability. That is being used by various state governments as the guide for water, rainwater harvesting and groundwater recharge structures. That is, of course, a standard document of Government of India also. And of course, you can go to another booklet from another book, rather, not booklet, a compendium, Artificial Recharge of Groundwater by Central Groundwater Board. So these are various various books which you can read for groundwater recharge, basically. What you need to understand further is that water is a multidimensional problem, and you need to understand and study more and more of the psychology, and more than psychology, sociology and social dynamics of the country and of the villages, because those are the people for whom we are working. So you need to understand the social dynamics also, the settlement patterns, and how the water is being perceived in the rural areas of the country, especially in Chhattisgarh. I think water is respected, water is revered. I've seen tribes in Chhattisgarh who respect water, who worship water. So that is what we need to learn from them. That is what we need to understand.
Thank you very much, sir.
Thank you, sir. I think it's quite time.
And it was a wonderful discussion. I am giving my email and my mobile number here in the chat. If anybody needs that, they can get to me on
Any questions, you can please send the mail to sir. And
mail or mobile also, that is on WhatsApp. Thank you very much. Thank you very much, Dr. Pramod. Thank you very much, Govindaram Sexari Institute, for inviting me.
There is one question on chat, sir.
Yes.
River water conditions of South India contaminated with pesticides, fertilizers, and other industrial effluents. Even if you reduce irrigation, this water unfit for drinking.
To treat this, you will have to pay huge money. Of course, yes. Of course, yes. You know, this whole decade is dedicated to what? It is dedicated to ecosystem restoration.
Yeah.
This whole decade is dedicated by United Nations to ecosystem restoration. And you know how much money is being put for ecosystem restoration? $9 trillion. And you know why $9 trillion? Because they say that if you don't spend this $9 trillion, the damage to ecosystem, the damage to the earth, the damage to the population would be triple of it. This $27 trillion would be in damages if you don't improve your ecosystem, if you don't restore your ecosystem. Groundwater is a part of ecosystem. You need to restore it at any cost, whatever cost it is, number one. Number two, the best technology for restoration of groundwater is stop pumping, stop over pumping, and add more and more rainwater to it to dilute it. That is the best technology, of course. So that is what is required, and that can be done for groundwater remediation. Again, political willpower and administrative willpower, and of course, community participation would be the key.
Thank you, sir. Now I invite our Chairman, Mining Engineers Association of India, Shri Suresh Hegde, sir, for his presidential remarks.
Yeah. Dr. Sudhindra Sharma ji and Dr. Nagaraj Hegde, Pramod, and other my friends who have joined the discussions today. I am really very happy that we got Dr. Sharma to address us this day about the rural water security. Really, water supply is a very essential thing, and it is going on since long time. I have worked as a senior geologist in the groundwater supply for the rural water supply, and I have faced certain difficulties, as Dr. Sharma has pointed out. One of such things I want to just tell you, sir.
Yes, sir.
I happen to be the senior geologist as well as the council secretary in the Zilla Panchayat as an additional charge. In one of the villages, as you said, you called him a sarpanch. Here he is called as Gram Panchayat chairman. He was opposing for extending the water supply to a small area in the same village. Why he was opposing was, it was his own personal problem regarding the caste and other things. But the real problem was that location of those groups of houses. It was about 10 to 15 houses only. It was located near to the seawater intrusion area. So I wanted to extend this water supply to that, and he was objecting. So this kind of political issues also, you said many times, the political issues are very important, and that we have to go for a social dynamics to understand it and to convince them. Finally, I took a lot of time, but I convinced the chairman, and I got the water supply extended to that area. So this kind of survey also we have done. And now, since you have pointed out, it is very important that we have got about 331,000 habitations to be covered for rural water supply, and restricting the groundwater use for only drinking water may be very difficult for us, because it is even the calculation and the other things. See, for the present, we want to give only 55 to 65 liters per capita consumption for the rural area, and about 85 liters consumption for the urban area. But that also we are not able to control it. For example, In my own house, I am telling you, I am consuming about 21,000 liters on an average per month, which is above the level assured by the government. So in spite of myself being aware of this situation, I have restricted. But there are some people, I have found that since because of my presence, my working in the water supply scheme, there are people who are using more than 200 to 250 liters per head in houses, and they are crossing per month about 30 to 40,000 liters, even up to 50,000 liters with a small in their house family members being less than 6 to 8. So this kind of we have to work out and create awareness among the public. Of course, I am very happy that you have suggested for increasing the rain gauge stations to measure correctly the rainwater, and the people's participation. Of course, it is very important. I would like to just quote one example of my very happy and satisfaction about the people's participation while I was working in Uttar Kannada district. Because of the submergence of their land in Kodsalli Dam reservoir, backwater, they were shifted from there to some place about 70 to 80 kilometers away from that area. But there, the people's participation for using the spring water and the groundwater jointly to meet the requirement was a wonderful thing. And it was, as you have quoted the example of one Bachu Singh, I met there the Panchayat chairman and the leader, more so a social leader, one Mr. Bhatt, who took care of the situation, and this spring water was used by them along with the groundwater but through borewells. But borewells were supplying only about 2 inches water. Actually 3 or 4 borewells they had, but that was not sufficient for them, and they used it. This type of course, security. I would like to point out one thing today. Recently, there is a trend to construct more of open wells for water supply of groundwater. So this open water supply, I have seen in many places, the security in my approach is that the surrounding area along the around the open well, that the source was not properly managed. So this, now I would like to suggest here that this is a very important for us to note down. Hello.
Hey, go ahead.
Hello, is there any problem?
No, continue, sir. Please continue, Sureshji.
Sir, I am very, very happy that you have covered lot of areas regarding this groundwater this, and of course there were some questions about the check dams, etc. So then naturally they should come. So the government is working very well, you know, for the check dams, for other artificial recharge structures, and the water harvesting structures, roof water harvesting structures, encouragement, conducting awareness programs, etc. So I am very happy that we had a very, very lively discussions with a very authoritative keynote address, rather, and a presentation by Dr. Sharma, for which I am fully satisfied, sir. And on behalf of the Mining Engineers Association of India, Belgaum chapter, as chairman, I thank you heartily, and I am very, 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 very happy for conducting this webinar and this special lecture. And I thank all those who have participated and all concerned for organizing such a wonderful event. I thank you, sir. Thank you very much.
Thank you, sir. Thank you.
My pleasure.
Now it's my duty to present the vote of thanks. We had a wonderful, informative and enlightening lecture with a lot of important information on groundwater management, especially taking us to rural areas. At the outset, I thank Rotarian Dr. Sudhindra Mohan Sharma, sir. Thank you, sir, for accepting our invitation to give this lecture and being with us even on Sundays. Thank you very much, sir. I thank R.H. Saukar, sir, Secretary of Geological Society of India, and all the Geological Society of India members. Shri S.R. Hegde, MEI Belgaum Chapter Chairman, for presiding over, and our Principal, Dr. N.D. Hegde, for being with us and supporting this event. I thank all the invitees, members of GSI, MEI, and all my colleagues, student friends, for making this function a grand success. Thank you, one and all. Have a great day.
Thank you very much.
Thank you and all.
Thank you, sirs.
There is a feedback link if you can give feedback, and which will be a record for us, for our college. Thank you. चला क्लोज करूया. Thank you, Priyanka.
हाँ sir.
Thank you, Yogesh. Thank you, Kavita, for joining.
Thank you, sir. It was a very informative talk.
Thank you.
It was nice experience. Thank you, sir.